Let's move to the next question. In this question, we have to prove that the points 7, 10 and negative 2, 5 and 3, negative 4 are the vertices of an isosceles right angle triangle. Let's work out the problem. Let us consider an isosceles right angle triangle. Here we have isosceles right angle triangle. Let A, B, C be the given points. Then we have A is 7, 10, B is negative 2, 5 and C is 3, negative 4. We have to prove A, B, C are the vertices of isosceles right angle triangle. One of the way to prove A, B, C are vertices of isosceles right angle triangle is to use the properties of isosceles right angle triangle. Here we have two properties. In the first property, hypotenuse square is equal to sum of the square of two sides. That means here we have a hypotenuse and the square of hypotenuse is equal to sum of the square of other two sides. For a triangle to be an isosceles triangle, any two sides must be equal. That means side 1 is equal to side 2. To prove triangle ABC is an isosceles right angle triangle, we have to find out the distances between sides, that is AB, BC and AC. To find these distances, let us consider the distance formula. If A x1, y1 and B x2, y2 are 2 points in a plane, then the distance between AB is small d, which is equal to square root of sum of the difference between x coordinates and difference between y coordinates. By using this formula, we can find out the distance between any 2 points. Let us take points AB and find out the distance between AB, that is equal to side of triangle ABC. Let's apply the distance formula. Here x1 is 7 and y1 is 10 and x2 is negative 2 and y2 is 5. Therefore, AB is equal to under root sum of the square of difference between x coordinates. Here we have x is 7, so 7 minus of minus 2 whole square plus difference between y coordinates. Here we have 10 minus 5 whole square under root. 7 minus of minus 2 is 7 plus 2, which is 9 whole square. 10 minus 5 is 5 and we have 5 whole square, which is equal to 9 square is 81 and 5 square is 25. Sum of 81 and 25 is 106. Therefore, side AB is equal to root of 106. Similarly, let us find the length of the side BC. In this case, we have x1 is negative 2 and y1 is 5 and x2 is 3 and y2 is negative 4. Let's apply the distance formula. Therefore, BC is equal to under root sum of the square of difference between x coordinates. Here we have minus 2 and minus 3 whole square. Similarly, difference between y coordinates 5 minus of minus 4. Here we must be very careful while applying distance formula. It is because small change in plus or minus will bring difference in the answer. Therefore, we have negative 2 and negative 3 is negative 5 whole square and 5 minus of minus 4 is plus 4. Therefore, 5 plus 4 is 9 whole square. Negative 5 whole square is 25 and 9 whole square is 81. Therefore, sum of 25 and 81 is 106. So we have the length of side BC is under root 106. Similarly, let us find length of side AC using distance formula. In this case, x1 is 7 and y1 is 10 and x2 is 3 and y2 is negative 4. Therefore, the distance between A and C is under root difference between x coordinate whole square, that is 7 minus 3 whole square plus difference between y coordinates whole square, 10 minus of minus 4. Let's simplify this. 7 minus 3 is 4 whole square, and 10 minus of minus 4 is plus 4. Therefore 10 plus 4 is 14 whole square. We know 4 square is 16 and 14 square is 196. Sum of 16 and 196 is 212. Therefore, the length of side AC is under root 212. Therefore, two sides are equal, that is AB is equal to BC and AC is greater than two sides. Then our hypotenuse becomes AC. In this triangle ABC, we have side AB is equal to BC. Let us find the hypotenuse square, which is AC whole square is 212. And we have the square of other two sides, that is AB square is 106 and BC square is 106. Sum of square of AB and BC is 106 plus 106, which is equal to 212. This value is equal to hypotenuse square. Therefore, in triangle ABC, we have hypotenuse square, which is AC square is equal to AB square plus BC square, and two sides are equal. Therefore, we can say that ABC are vertices of an isosceles right angle triangle.